Hi guys. Okay, here we are going to solve a differential equation by doing separation of variables. So the first step is to bring the y's to one side and the x's to the other. Usually you'll bring the y's to the left and the x's to the right. It could be different, but that's just usually how they're set up. So in this problem, I can multiply both sides by y. That'll get rid of that. So that'll give me y times dy dx equals 3x squared plus 4. Then I can multiply both sides by dx because that has an x in it and I want all my x's on one side. So that's going to cancel that. So now what I have is y dy equals 3x squared plus 4 dx. Alright, so now what we're going to do is integrate both sides. So go ahead and put the integral in front of both sides and just do it the normal way that you've been doing integrals. So the integral of y is y squared over 2. And we would usually write plus c, but we're just going to write it on the right-hand side only. So this integral right here is going to just end up being x to the third and then plus 4x. And then over here we can plus c because we really don't have to add c to both sides because then it's still a constant when you move it to one side. So now we're going to get y alone. So we'll multiply both sides by 2. So over here, this gives me y squared equals, and I can distribute this 2, so 2x cubed plus 8x. Now here's the other thing. Plus 2c. c is a constant. If you multiply it by 2, that still gives you a constant. So instead of writing plus 2c, let's erase that, you can just write plus c because 2c, c, still constant. All right, now we're going to get y completely alone, so we're going to take the square root of both sides, like that. So y will equal plus or minus the square root of 2x cubed plus 8x plus c. And there we do have to leave c underneath the radical because now it's part of a quantity. And now here comes the initial condition. So y of 0 equals 1. So I'm going to plug 0 in for each x, and the 1 gets plugged in for the y. So I have 1 equals plus or minus the square root of 2 times 0 cubed plus 8 times 0 plus c. All right, now I'm trying to solve for c, so I will square both sides. So that gives me 1 equals, and now all that's left on this side is just c, because squaring the radical, that cancels out, and squaring the positive or squaring the negative, that just becomes a positive in front of the c, so c equals 1. So the final answer would be y equals plus or minus the square root of 2x cubed plus 8x plus 1. And so that is the solution to the differential equation. And actually, as I'm taking a closer look at this, it would only be the plus, not the minus. Because think about if we plug that initial condition back in again. It's supposed to be y of 0 equals 1. So if I have 1 equals the square root, and then this is all going to be 2 times 0 cubed plus 8 times 0 plus 1. The only way this is a true statement is not if I have a plus or a minus. It's only if I have a positive, because then 1 would equal the square root of 1. So 1 equals 1. So let's just fix that. We'll take that away from the answer. And so that is our final answer. Now I've written one more problem on page 2 over here. So the first step with this problem, the y's and x's are kind of all mixed together. So the first step would be on the right hand side, I could factor a y out of both terms. So that leaves me with x plus cosine of x equals dy dx. Now that will allow me to divide both sides by y. And why don't we do this at the same time? Let's multiply both sides by dx. So this is gone on that side. The y's are gone on that side. So I basically have over here 1 over y dy. And on this side I have x plus cosine of x dx. So all the y's are together, all the x's are together. So now I'm going to take the integral of both sides. So the integral of 1 over y is the ln of y. And remember, I'll just add c to the right-hand side. Then this integral is x squared over 2 plus sine of x plus c. Now we're trying to get y by itself. So what I'd have to do is raise, I'm going to make e be the base and make the sides be the powers. So now I just put an e on both sides, but it's e to the ln of y equals e raised to that whole exponent on that side. All right, now what happens here is e to the ln cancels, so I'm left with y equals e to the x squared over 2 plus sine of x plus c. Now you've probably seen this in class. When you have a plus c up in the exponent, because of properties of exponents, it can come down in front of the e. So let's just do that too. Y equals c e to the x squared over 2 plus sine of x. It's because of this. The e can get split up into x squared over 2 times e to the sine of x times e to the c. Because we know by properties of exponents that if we wanted to combine all this, we would just add the 3 exponents back together again and have the base be the e. Well, here's the thing. E to the c, since c is a constant, e to the c is just another constant. It's just another c. So I just basically stick that c right in front, and I don't split apart these two e's, I just leave them together. And so I'm just going to erase all this because that might look confusing if we leave it there. But the finished product is right here with a c just written right in front of the e. I also got rid of the absolute value around the y because if we allow that the c can come out positive or negative, then we no longer need the absolute value around the y. That will just be determined by the initial value that we're about to plug in. So let's just recopy up here. We have y equals c e to the x squared over 2 plus sine of x. So according to my initial value, we're going to plug 0 in for x and 1 in for the y. So 1 equals c e to the 0 squared over 2 plus sine of 0. So we have e to the 0, because the sine of 0 is also 0. So we have 1 equals c times 1. So we end up with 1 equals c. So if I rewrite my final answer, c is just 1, so I won't even write that, but it's just e to the x squared over 2 plus sine of x. And that would be our final answer.